Simply mechanisms. One in a series of videos where I look at organic chemistry mechanisms. And here I look at the reaction of bromine with ethene. The mechanism is known as electrophilic addition. The bromine molecule Br2 is non-polar. As the covalent bond is between two identical atoms, there's no difference in electronegativity, and that bonding pair of electrons between the atoms is equally shared. Both electrons spend time around both atoms and an equal amount of time around both atoms. Here's my ethene molecule, and we have a carbon-carbon double bond where we have 4 electrons concentrated in the same region. The double bond, of course, is made up of a sigma and a pi bond. It's worth pointing out that all 6 atoms of the ethene molecule lie on the same flat plane. Look at this animated molecule at the bottom. You can see when it's in the correct orientation that all of those atoms are on the same flat plane. And also that the 2 electrons of the pi bond are found mostly, or most of the time, either above or below the flat plane, represented by these red and blue clouds above the flat plane of the 6 atoms. So here's my bromine molecule, and as it approaches or passes by the carbon-carbon double bond, that region of high electron density, look what's happening now to the bonding pair of electrons in that bond between the 2 bromine atoms. The bonding pair of electrons will begin to spend more of their time around the bromine to the bottom, and we have a dipole induced into the Br2 molecule. We'll therefore have a delta positive on the bromine at the top, so that it's somewhat electron deficient, and a delta minus on the bromine at the bottom, indicating that it's somewhat electron rich. Now, as is typical of these organic mechanisms, we have a 2-step mechanism. The first step is the slow step, also known as the rate determining step. And here's a curly arrow, so-called curly arrow, that in all cases tracks the movement of a pair of electrons. And this one is showing that the 2 electrons, specifically of the pi bond, remember it's sitting out from the flat plane of the molecule, and is also, the pi bond is also a weaker bond, so it's the bond that's going to break, and both electrons come around to form a bond with the bromine at the top of the Br2 molecule. And this second curly arrow shows that at the same time the 2 electrons of the Br-Br bond come around to the lower bromine, so that bond is breaking heterolytically. Hetero means different. The 2 bromines are being treated differently, as the bottom bromine is getting both electrons of the bond. Now, there will be a stage where the bromine at the top there will lose a share in its pair of electrons and will effectively be down an electron and will be a Br plus ion, an unusual species. A species with an unpaired electron is called an electrophile. So that's the electrophile in this particular mechanism. And note that it's called electrophilic addition. Now I'm going to show how our intermediate is formed. And I'm going to show that the 2 electrons of what had been the pi bond between the carbon atoms is now going to be used to form a covalent bond with the bromine that had borne the delta positive charge. So that bromine lost a share in the pair of electrons with the bromine below it, but it's now gained a share in the pair of electrons that had been the electrons of the pi bond. Look at the carbon to the right of this intermediate. It now bears a positive charge. Why? Well, when the pi bond broke, it lost out in that the 2 electrons of the pi bond went to the carbon on the left. So it lost effectively the electron that it will have contributed to form the pi bond originally. It's down 1 electron and bears a positive charge. And the bromine here will have to be shown with a minus charge. Remember that as a result of heterolytic fission, the lower bromine atom got both electrons, so effectively has an extra electron and therefore a single minus charge. Then in the fast step, we can see why this will be the fast step, we have the positive and negative ions reacting with each other. They're clearly going to be attracted strongly to one another. And we have a third curly arrow, which again tracks the movement of a pair of electrons. Those 2 electrons, represented by the 2 dots, came from the 2 electrons of the covalent bond in the bromine molecule. But they're now shown with this curly arrow to go and form a bond between the bromine and the carbon that bore the positive charge in the carbocation. And here's the structure of the product. We have ended up now with a bromine on each of the two carbon atoms. We've ended up with a haloalkane molecule. So why is it called an addition reaction? Well, you can see that we've added together two molecules, ethene and bromine, to form a single molecule as our product. So just one product, hence addition. And of course earlier we saw that an electrophile is produced in the slow rate determining step, in this case a Br plus electrophile, hence electrophilic. And the name of the product 1,2-dibromoethane. So this has been one in a series of videos entitled Simply Mechanisms. Do please consider looking at some of the others in the series, and thanks for listening.